So I started my conversation about the valence shell electron pair repulsion theory and how it affects molecular geometry, that is to say, the shape of the molecules that form. I like to use this idea of a ball and electron pairs arranging around the ball in such a way that the repulsion is pushing them so that they're as far away from each other as possible. The first scenario involves two valence shell electron pairs marked by these small pieces of yellow tape. Obviously, to be as far away from each other as possible, we'd have one on each side of the ball 180 degrees apart. Think of this as the North Pole and the South Pole. So that's as far away as they can get around this sphere. The second scenario would be we have three pairs or three groups of electrons around the central atom. And at that point, they're going to move a little closer but still be as far away from each other as possible. 120 degrees is an even distribution around that sphere or circle. 120 degree angle of separation. When we introduce a fourth pair of electrons, then we get into a more three-dimensional, non-planar kind of scenario where we have a tetrahedral arrangement of the electron pairs, trying to get them evenly distributed as far away from each other as possible. And that's going to be about 109 degrees. If I introduce a fifth pair of valence shell electron, I'm going to have one on the North Pole and one on the South Pole and three on the equator. That's going to give us angles of 120 degrees at the equator and 90 degrees between the North Pole and the equator, or the electron pairs that are along the equator. 90 degrees and 120 degrees. It is possible with a compound like xenon hexafluoride that you can have six pairs. And at that point, we're going to have four pairs on the equator, as I've called it, to try to give us some sort of an orientation, and a pair at the North Pole and a pair at the South Pole. So that would be the arrangement for six pairs of valence shell electrons around the central atom. 90 degrees at the equator, 90 degrees from the North Pole to the equator, 90 degrees from the South Pole to the equator. That's as far apart as those valence shell electrons can get, 90 degrees. This would result in an octahedral geometry.